Hey everyone. So in the previous video, I started to introduce the task for our textual data section for this week, which is identifying the authorship of 11 essays in the Federalist Papers where the authorship is not clear. Okay, and specifically, we're going to focus on the comparison between Hamilton and Madison. All right, so. The first step, as I mentioned in the previous video, is to identify the dependent variable. And that's the outcome that we want to predict ultimately, and also that's the kind of what we base our model on, or what we use as a dependent variable in our model to predict the outcome for the essays where the authorship is unclear. Okay, so what we're going to do here very quickly is just create a vector of length 85. So for 85 essays in the Federalist Papers, and we're just going to, based on their numbering, identify the authorship by Hamilton, Madison, as well as joint authorship by Hamilton and Madison, as well as John Jay, for those authorship numbers where the authorship is identified, and then we have 11 additional essays where it is contested. And our goal now is to identify, based on the comparison or based on the essays where we know the authorship, to predict who ultimately authored, who was the author of the remaining contested essays. So that's the outcome that we want to predict, and that's what we're going to the dependent variable in our model ultimately. Right? And so if we look at this vector, of course, this is just a frequency table with 11 contested essays, 51 written by Hamilton, 15 written by Madison, and then 3 jointly and 5 by John Jay. And now the next crucial step is to create predictors that we can use to identify the authorship, right? And so here we're going to use the TM, the text model package. And there are other types of packages like Quantita and TidyText that allow you to deal with text data in R as well. If you're interested in getting more into text analysis, I can give you more resources, and I would definitely recommend you to take the 935 course sometime in, not the next semester, but probably again the semester following that, where I'm going to show you some of those techniques as well. The first thing we're going to do here is we're going to load a set of documents that are in the Federalist folder, and all the individual files have this pattern FP, so they the file name contains FP as a pattern. Okay, so all these are loaded and turned into a corpus. A corpus is just this collection of documents that we're going to work with. Okay, and then there are a couple of pre-processing steps that we're going to engage in, and each of these pre-processing steps are going to be completed using the tm_map command. Okay, and we always start with the previous first the raw corpus, and then what we do is we transform them, all the characters or the string vectors, all the characters into lowercase characters. That's the first transformation. Then we strip additional white spaces. We remove multiple white spaces, so to speak, so there are only individual single spaces between words. We remove punctuation, remove numbers because we're not interested in those, and then we convert this into a document term matrix, and that's kind of one of the key basic data types that we encounter when we work with text data. And the idea behind a document term matrix is to turn the text into a large sparse matrix where each row is one document that is included, so one of our 85 essays, of the Federalist Papers, and each column, each variable, so to speak, is a token, a term that appears in one of the documents. So you could think of the kind of all the columns, all the variables as the entire vocabulary, the set of all words that appear across all those documents. And the entries in that large matrix basically contain the counts of how often does a word occur in a given document, right? So of course, this document term matrix is incredibly large, especially when you have large collection of documents in your corpus, right? So here with our 85 Federalist Papers, we have, of course, if we look at the dimensions of our document term matrix, we have 85 rows, so that's for our 85 documents, and we have 8,594 columns. So that's 8,594 individual tokens, individual terms that kind of appear in any of those documents, right? And if we look at just a little snapshot of the document term matrix, the first 4 rows and just a couple of 4 different columns, we see these are the different terms, as I mentioned, kind of the vocabulary that is included across the entire corpus. We have, for example, address or admit or adopt, and we see each of those entries in that matrix are counts of how often this term appears in that given document, right? So address appears in the first essay, doesn't appear in the second, doesn't appear in the third, but appears in the fourth. Adopt, for example, is mentioned, is included twice in the second one, only once in the first one, and so on, right? So that is a count of words for each document, for each word that appears across all documents, right? And so some words, of course, don't appear in one of the documents, then you have a 0 here, right? And note how this kind of one turns text that you usually wouldn't think of as kind of, you know, a data matrix into something that is much more manageable, kind of, and that we're used to, which is just a 2-dimensional array with a number of rows for observations and a number of columns for variables. But we make a lot of kind of simplifying assumptions, and we're essentially losing a lot of information, right? One of the crucial assumptions is that we're losing information about the order of words that appear in this document, right? So since this is now a data frame that only contains counts of words, we lost all the kind of information about positioning of the words or how words go together, to what extent there's, for example, a negation of a word, so I don't address or something like that. So these are all crucial things that potentially crucial information that we miss. And so this assumption that we disregard the order of words or punctuation and thing, or specifically the word order, is what is often called the bag of words assumptions. So essentially, we're treating this text as if, you know, each individual, all that matters is whether a term appears and how often it appears, but not in which order. So we're just kind of throwing all the terms that occur in a text in a big bag, and then count the words irrespective of in the order in which they appear, right? That might seem like a very crude simplification, and it certainly is, and there are, of course, more advanced methods that kind of don't make this assumption and look at word order specifically. But one interesting thing is that this assumption or the simplification works surprisingly well, right? So we can still extract a lot of interesting and useful information, even if we, you know, make this bag of words assumption and just count the number of words that are in the text. And that's what we're going to do now, right? But we can't really stop here. The raw counts have certain problems and are not necessarily reliable predictors. Why is that the case? The problem is that these documents, of course, vary quite wide, or very have strong or high variation with regard to their length, right? So if we here look at the document lengths or the number of words basically across authors, we see that there's wide variation in average length of documents between authors, right? So Madison wrote longer essays, Jay shorter essays, and so on, right? And so that means if we use raw counts, then these raw counts could be essentially biased or not directly comparable between documents, because certain documents just contain a larger number of words overall, right? So what we should focus on is not the total count of terms across documents, but essentially we want to focus on word rates. So how often a word occurs in a given document proportional to the document length, right? And of course we can easily compute that by dividing the word count that we already extracted by the document length. And if we want to look at the rate instead of the proportion, we can multiply by 1000, and then we get this document term matrix kind of converted into word rates rather than raw word counts. So this is just the computation that we did here, dividing by the document length, which is of course just the sum of all or the rows, sum by row, summing all the word counts for each document will give you the total number of words in terms in each document. And now if we compare this to the previous, where we had the previous document term matrix where we had individual counts, now these are basically expressed as word rates, okay? But this is still not right, not quite there. The problem is that we still have, since this is such a large matrix with so many words, there are just a lot of predictors that we can take into account, right? And so as we get to more advanced methods, we'll look at other kind of ways of identifying useful predictors or handling large numbers of predictors like that. But with the methods and techniques that we know so far, 8,594 is definitely too many predictors to identify authorship, especially given the fact that we only have 85 observations in total, right? So way more predictors than we have observations. And of course, we will not be able to fit any reasonable model, at least with the techniques that we know so far. So given that this is way too many, and given the kind of goals and arguments regarding kind of what types of text and language we want to focus on in order to identify authorship, we'll just focus on a subset here, right? And specifically we will focus on, and I said specifically again, if you watched the previous video, we're going to focus on a set of terms that are kind of like part of this habitual way of speaking, right? So people might be more inclined to say, like, use like considerable, or use something like consequently or commonly. Terms like that that you can use as part of kind of your language habits, but not necessarily. You could express yourself using or focusing more or less on these specific terms, or use other terms instead, right? So for now we'll disregard all the other terms, and we'll just focus on those terms and how often these terms appear in each of those documents, and use that as a predictor to classify authorship. All right. And so if we kind of just subset our document term matrix according to those words that I identified here, we see now the proportion, or the word rate, I should say, for those key terms that we're interested in across 85 different documents, right? Okay, so now we have our set of predictors. We have the outcome that we want to predict, and so now we basically want to combine those two pieces of information and create our dependent variable and kind of attach it to this data frame, right? So as I said, our dependent variable is the identity of the author if we know it, and then based on that association, we will kind of try to make a prediction about the authors or about the essays where the authorship is not clear, all right? And so as I mentioned, we had this this vector author that contained authorship of the numbered essays in the Federalist Papers. And what we're going to do now is we're going to combine those together, right? So we're going to create a new data frame where the first variable is just the number, the essay number. Second, the first variable is just the essay number. Second variable is the author information that we previously saved in a vector. And then we have our document term matrix, only focusing on the specific terms that we will focus on, that again kind of capture this kind of habitual language use, and we're going to focus on that to identify authorship. Okay. So after now that we have our data set kind of set up and ready to go, in the next video we will talk about, you know, kind of separating the data that we have into training and test set, and then actually running a model.